For f***'s sake. What does it take to go from this mess to this piece of futuristic design? Stick around to the end of the video to find out how to win one of these unique prototype AI streaming microphones, which we'll cover how to make in today's video. This video is sponsored by PCBWay. So you can see the device that we want to build, but in order to understand how to do that, we have to go back a little bit, because this wasn't as easy as you might think it should be. It certainly wasn't as easy as I thought it was going to be, but we'll get to all of those reasons soon enough. In my last video, I went through a really simple solution to get up and running with Google's Gemini 2.0 Flash Multimodal API, where we could both stream audio and video using our web browser. In order to work with these sorts of models in products like smart glasses or robots, we really need to understand how we're going to stream audio from those products into these models. Now, while my last few videos have been pretty much just about coding, and I code every single day, what I really enjoy doing now is actually developing hardware. So after weeks and weeks of messing around with AI, pulling my hair out, I was just really looking forward to actually building something physical, something tangible. I mean, that's what making's all about. So to get things underway, let's start by building up a really simple microphone, and we'll go from there. We're going to use this amazing little ESP32 S3 board called the Tiny S3 from Unexpected Maker. It measures just 18mm by 35mm and is perfect for this type of application. Thank you so much, Unexpected Maker, for supplying the Tiny S3 board that we're going to use in this build. You can find the details of Unexpected Maker's store and their YouTube channel in the friends of the channel in the description below. All right, let's crack on with hooking this microphone up. In this hookup, we're using a tiny little MEMS microphone. This is an INMP 441 omnidirectional microphone. It uses the 3.3 volt output from the Tiny S3 board along with the ground. We connect up the SD, SCK and WS pins to our chosen GPIO pins on the board, and we tie the left-right channel, or LR, to ground to force a left channel input. Now the fun and games really begins, because we not only have to write the code on the ESP32 to stream the audio, we have to really think about how we're going to route that streaming data all the way up to the Gemini model. Now, we're starting to deal with quite a few moving parts in terms of code, and having messed around with audio quite a lot over a number of years, the schoolboy error here would be to think that we need to pack everything into a single server and somehow hope and pray that it's going to work. More often than not, it just won't. So let's take the time to update our architectural diagram from the last video to understand how we're going to integrate it, and we can go from there. We're going to start by removing our old client app, but we will be keeping our existing Python server. And of course, we'll be adding the ESP32 microphone to stream the audio in. The audio routing server has one job here, which is to keep the data packets flowing at a consistent rate into a buffer that can be eventually sent to Gemini via our client app. I've created a new client app that allows us to not only communicate with Gemini via our Python server, but also allows us to work with our audio stream to configure it correctly. Our Python server has a new WebSocket added to receive the audio data from the client and continues to return responses from Gemini back into the client app. As before, Gemini remains our model in the cloud, that we are connected to with the Python SDK WebSocket connection. So some of you are probably wondering, why didn't we just modify the Python server to deal with this streaming audio? And it's a good question. Now, audio data is extremely fragile. And when you're dealing with streaming audio data, it's even more fragile. And what I mean by that is that in order to make audio work in a solution like this, there is one thing that matters above all else, and that is consistency in the data stream itself. Everything from the sample rate to the buffer size, how even the audio channel makes a difference. I've had Google respond to me in Japanese just because the gain on the audio wasn't good enough for it to be able to make out I was speaking in English. Sometimes you'll get things like silence or static or noise or nothing at all, and it can be extremely frustrating. Now, the ESP32 is an amazing chip, but in order to get consistency, we are going to need to squeeze the life out of it and use both the cores that it has to push that data out. Google Gemini requires 16-bit PCM raw data with a sample rate of 16K, while OpenAI requires uncompressed 16-bit PCM with 24K data as well. Now, in my testing for weeks and weeks of this stuff, I could get it to output 24K sampled rate data, but I couldn't do it consistently. And again, that is the key. So that's why we're building a separate server, so we can look at that data en route to the model. We can analyze it. We can make sure it's actually working and rule it out as being any part of a problem if we do have a problem with the interaction of the model. That's why we have a separate server. Okay, so we're all set up, and just to give you a little bit of a view of what's going on, obviously on the big screen here, I've currently got 4 solutions running. We've got our Python server, our Node server, we've got our ESP32 code, and we've got our client app. Over on that screen, in the corner is our client that is running. And obviously I'm gonna grab a screenshot of, or screen capture of that running at the same time. And down on the little desk, we have our ESP32 that is running and ready to go. All right, let's switch over to the screen capture and we'll go from there. Okay, so we're inside our client. It's nice and simple. You can see what we're trying to do here. I'm gonna just click connect and the whole system will just sort of come online all at the same time. What you will see is that we have quite a lot of noise in this room because I have an air conditioning running. It's extremely hot today. So I'm running that. You're going to see that noise come through on this plot, and I'm just going to give it a few seconds to see if it'll calm down. It may not, and that's okay. I'm going to increase the gain a little bit, and then we're going to request if Gemini can hear us clearly, of course, and hopefully we'll get some pretty rapid responses from the model. Anyway, let's give it a go and see how things are today. Hey, can you hear me nice and clearly? That's fantastic. How are you going today? So after wiring everything up and days upon days upon days of ESP32 coding, we finally have consistent, reliable audio streaming up to the Gemini model. Now, it's at this point that I just needed a break from coding. And I'd been looking at a feature in Onshape a while back that I just didn't know how I was going to use it. This is where we can project a shape onto a solid in order to create a face. And so it was at this point that I thought maybe I could create a prototype case for the microphone to make it a little bit easier to handle. Yes, this gets really annoying really quickly. I'll go through the rollback scenario here so you can see how each step shapes our output. I started by creating a pebble type solid that was large enough to house the board and the microphone. And then I created a sketch using linear patterns of hexagons. Then, using the split feature, I applied the hexagon sketch to the pebble and we end up with a bunch of faces to work with. I then set about carefully moving faces in a random selection, which resulted in this pretty funky exterior that I was happy with. From there, I modeled the cavity and I created a plate to close it all up. I wanted it to be pretty generic, so I can now model the plate to hold the tiny S3 and microphone however I like, along with a port for the USB cable to power it. For aesthetics, I made some cutouts and added a prototype label slab. One of the features I really love in Onshape is, of course, the ability to render things. And given it was my intention for this to be some sort of cyberpunk futuristic looking device, this is what I came up with, which may not be everyone's cup of tea, but I really liked it. So I quickly knocked it out on my resin printer to check the dimensions and the overall general feel of it. And then I went online to PCBWay to start the process of taking this prototype up to a whole other level. I've been a customer of PCBWay for quite a long time now, as I'm sure many of you are as well. And I've always had a great experience, whether that's with the things that I've had made and they've sent to me, or the customer service that occasionally I need to speak to sort something out. I was absolutely over the moon when we started talking together about some of the projects that I want to build for this channel. And they said, let's go a little bit further here. Now, PCBWay have agreed to not just sponsor this video, but have committed to being a long-term channel sponsor, which is absolutely amazing because it means that we're going to be able to build some projects on this channel that otherwise I probably wouldn't be able to do without their support. Now, speaking of support, they've sponsored a lot of YouTubers over the years, and the only thing I ask is that you consider supporting them if you're looking to make something, just as they support people like me. I'll leave a permanent link to a discount code in the description down below. I wanted to see just how close I could get to my renderings in Onshape, and so I went into the 3D printing section first and then looked at all the material options available. What's really cool here is that we get a good description of the various resins and metals available. Generally for this type of product that doesn't have a high specification requirement around things like UV protection, fluid blocking or outcasting, in other words, an indoor product, I'll go with the standard UTR 8360 in this case, where I want to apply surface finishing through either painting or dyeing. So I selected that and then specified our finishing choice, which in this case is a matte paint finish. You'll notice you have a choice of colors here, but you can also open up the Pantone color chart and find the values you need. In this case, I think the 2010 U color matches what we need, so I just add it in the box and submit it. I progressed with the rest of the order using our exported models, but one item I'm really excited to check out is this little greeble button that I opted to be made in 3D printed titanium. It's pretty cool for sure. So while I was waiting for the order to arrive, I designed an internal cavity part to hold the tiny S3 and the microphone in place. I printed this and it looks like it should all fit. Within a few days, the delivery arrived and it was time to check out our order, which was organized and clearly securely packed. I was so pleased with how vibrant the colors turned out, and the quality of the print is really incredible. Of course, the very small but very cool titanium button was a super nice touch. Now I just had to add some embedded nuts, glue on the buttons with some epoxy, and put it all together. I think it turned out pretty well. It certainly does great at hiding all of the wires and the rubbish and just making it work. Now, it's a prototype. We could take it further, obviously adding things like LEDs for status, power management, batteries, all of those sort of things. It's literally just a starting point. Thanks again to PCBWay and Unexpected Maker for making this project happen, and of course for sponsoring the channel. I happen to make several units of the AI streaming mic, so I'd like to give one of them away. Entering is the easy part. First of all, just make sure you're subscribed to the channel and put a comment down below and just tell me what you're working on or what you want to be working on. Could this help you make something? Just let me know. All right, that'll get you a single entry into the pot. For my Patreon supporters, you'll automatically get 10 times the number of entries as to your subscription plan. So for those very kind Tinkerer subscribers who pay just $3 a month, you'll get 30 entries into the draw, and so on and so forth. I'll announce the winner in 2 weeks' time in a community post here on YouTube, as well as over on Patreon. So that's it for another video. Please do consider checking out our sponsors and friends down in the description below. And as always, a special thank you to those people who are Patreon members that are providing me with support and just motivating me to keep going and keep making videos. All right, I am the Old Man Maker, and I'm hoping you keep breaking stuff so you can keep trying to make stuff. That's what it's all about, right? All right, see you in the next one.